Hey there, welcome to the Confident Chemistry Teacher podcast. I'm Kim, a high school chemistry teacher who's still in the classroom teaching chemistry and refining what actually works with real students. This podcast is all about practical chemistry teaching strategies, labs, and systems that make teaching feel more manageable and more confident. So let's get this reaction started. Hey chemistry peeps, in this episode, I'm taking you inside my mole unit, not as a day-by-day plan, but how I think about teaching it. I'll walk you through how I introduce the unit, how I teach and practice the core skills, and how I check for mastery before we ever get to the test. My goal is always the same, helping students actually learn chemistry, not just trying to survive the unit. So before we jump into the activities that I do, I tell myself and my students that the mole is really a unit about skills and not about memorizing facts. And just like they would if they were part of a sports team, any skill needs to be practiced. And so as we go through this unit, it's going to be really important that they do the practice so that they can learn those skills to be successful. By the end of the unit, I'm wanting the students to do the traditional mole to gram, mole to represented particle, mole to liter, and of course backwards conversions. I want them to do double conversions going from like grams to representative particles. And then in the second part of my unit, I teach percent composition, empirical, and molecular formulas. I think one of the things that makes this unit especially hard is this is like the first math unit that we're seeing since the beginning of the year. And when we do our mole conversion, students have to remember how to do dimensional analysis, and they haven't seen that really since August or September. So I do try to remind them, hey, we did actually learn this before. And as I talk about dimensional analysis, I try to show them that it's a tool that they can use to convert from one unit to another, not some random trick that they have to do. Because this unit is so skill heavy, I'm really intentional about how I introduce it, and then I also make sure that I am chunking the content. I usually start the mole unit off with talking about scale because as we know, 6.02 times 10 to the 23rd is a really big number. There is a pretty short TEDx video that I like to show called How Big is the Mole? It does a really great job helping students visualize how big a mole is. One of my favorite examples is they show like a mole of basketballs would make up like the whole earth. And then right after that, they talk about if you had a mole of money, you could spend like $1 million a day and still have most of it left over when you pass away. So I like that video. It's short. It gives them an idea about actually how big a mole is. From there, I remind students that as scientists or chemists, knowing the number of atoms present is really helpful for figuring out like how much product we're going to be able to make. But then I ask them, can you see an atom? And of course the students are like, no, we can't. So then I talk about, well, how can we count the number of atoms if we can't see it? I also like to mention to students at this moment about what unit do we use to measure an atom's mass in. And of course, it's the atomic mass unit. And then I ask, is that a number that is like, that we could see? And, or, like, is that a number that we like commonly use? And of course, they're like, no. And so I remind them that we usually use grams when we're measuring mass. So to help them see how AMU is not really a unit that is usable in the real world. Then we discuss how we can use mass to actually count the number of atoms. And so to help students, I have this activity called measuring by mass, and I use paper clips. And basically the students can learn by doing this that if they know the average mass of a paper clip, that they can measure a large mass of they can measure the number of paper clips in a large mass pretty simply. And then I remind them that that's basically what we're doing is we know the mass of an individual atom. We can take those AMUs and convert them into grams. And then grams is something that we can use and count in our everyday life. So I let them see from that activity how we can really actually count the number of paper clips or atoms by measuring the mass. So for direct instruction, even though this unit is a math-based unit, I still rely on my Google Slides for some direct instruction. The slides aren't just about showing the answers, they're really about like modeling how to think through the steps. And in fact, in my Google Slides that I have for this, it literally says like step 1, step 2, step 3, and so on. I like to start off with what I find is pretty challenging for the students, but it ties in nicely with the paperclip activity that we just did. So I like to teach molar mass first and then mole to gram conversions. And of course, whenever I say that, I'm always like mole to gram, gram to mole. So definitely going both ways there. And since I do think this is a little bit more tricky of a conversion, I like to teach it on the first day so that the kids can get more practice as we're learning the other conversion factors. Once they have a handle on the mole to mass, or what I call mole to gram conversions, then I'll go ahead and I'll introduce the mole to representative particles, moles to liter conversions, and the kids find that a little bit easier since obviously those numbers, those conversion factors stay the same. Then I'll go ahead and I'll introduce multi-step, or what I call double conversion factor problems. And then the last little piece that I talk about is the percent composition, empirical, and molecular formulas. And I do try to tell the students that think about this not just as converting units, but they're converting from one usable piece of information to another usable piece of information. A little teacher tip here is when I made my slides, there's obviously a lot of math involved in them. And so formatting the math is pretty challenging in Google Slides. What was a lot easier for me, and the kids appreciated just as much, if not more, is I literally just took a picture of the problems I had of them worked out, and I embedded those photos of the worked out problems into the Google Slide. And I just thought that was a lot faster than trying to format the math problems. And the kids liked this because it looked more like what I was doing on the board and then what they were going to do and replicate on their worksheets. The next thing is practice. So I always kind of like to joke that I always try to plan in some boring practice and then some fun-ish practice. So since this is a skill-based unit, what I'll do is we obviously just have worksheets. I feel like they're a good tool, and the worksheets will help the students practice these skills. Little teacher tip here is I usually try to give the kids like 10 minutes to work independently on the worksheet and then have them work with their partner for 5 minutes. If the students aren't really putting in good effort during the 10 minutes, then it just turns into a 15-minute silent session. But somehow having the 5 minutes to work with their partner really does motivate them, and then it gives them an opportunity to ask questions that they might not otherwise ask me. And then I like to do what I call more active or fun-ish practice. So that might be like rock, paper, scissors, where the students will just solve problems based off of like whoever wins rock, paper, scissors. Of course, there's a lot of whiteboarding here. They really like to write the things on the whiteboards. Or we'll do some like small group partner activities. I really like to do small group practice for our practice tests at the end of the unit, again, so that they can help each other. And when I make those small groups for the review, I usually try to incorporate one student who I know has it, and then like a couple students that maybe need a little bit of help. So I think that both matter. I think the boring or the independent practice really matters because I want the students to be confident in their own skills and not rely on their neighbors. And then the active practice is really good. One, again, for motivation, but also sometimes you'll have those quieter students that won't ask you a question, but maybe they'll ask their neighbor a question. And so I think that both support student learning. And then after the students have had time to practice in different ways, I want to make sure that there's like a clear checkpoint before we move on. And the next thing I do after this practice is I'm going to have them do a mastery check. For me, a mastery check is just a half a piece of paper. And in this unit, it's just usually like 3 questions. And the 3 questions help the student and myself assess, are the students getting it? And I think I've mentioned this before, but I remember sitting in my own chemistry class. I would have like a quiz a few days before the unit test. And that quiz was like a review over the whole unit. And then when I got the score back, I really didn't have enough time to go back and relearn what I should have learned, what I wasn't understanding. So I really like to do a mastery check, kind of like that mini quiz after each unit I do. So in this unit, I'll do a mastery check on molar mass and moles. I'll do one on mole to represented particles and liters. I'll do one on percent composition. And so notice I'm not actually doing a mastery check after each skill. I just really like that order. One, because the double conversion factors are not like a huge focus on the test. And then we are learning the empirical and molecular formulas like right before the test. So hopefully that'll still be fresh in their brain. The way that I work this is we do it in class. Students have an opportunity to retake it. They'll take the quiz initially. I'll grade the quiz. I'll give the quiz back to them, go over the problem or two that students miss the most, and then students have an opportunity to retake that quiz. And then sometimes if a student comes in for that retake and they're still not really understanding what they're doing, I'll sometimes even give them another retake after that if they're really showing like a lot of initiative and really, really trying to learn it. I don't give that second retake all that often, but like if students putting in the effort, I want to acknowledge their hard work. I also like to put these mastery checks throughout the unit because it creates a sense of urgency for students. So if they know they have a quiz coming up soon, it's like they're going to have to learn that skill, and until waiting till the end of the unit to try to cram everything in and try to learn it before the test. Then also the mastery checks give me an idea about are the students learning what they need to learn? And we all have curriculum guides, and it's not always easy to take another day, which you could definitely take another day if you're finding that your students aren't getting it. But I'll take the results, I'll see what problems they're missing the most, and then I'll maybe add an additional warm-up question like the next couple days covering that topic. I might give them a worksheet with answer key, like I'll just post it on our daily slides and be like, hey guys, here's some extra practice if you need it. Or sometimes I'll also link a short video on how to solve that problem. I really like Tyler DeWitt. If you haven't watched his videos, he does a really great job explaining some really basic concepts. And this will give my students an opportunity to continue to practice those skills or to learn them before we take the big unit assessment. So the next section is when we talk about labs. Really, we want students to be applying what they're learning and to make sense of what they're learning. So as I mentioned earlier, I really like that counting by measuring mass activity that I do in the opening day or two of my unit. Again, it's stressing this idea that you can count the number of particles by measuring the mass of your substance there. Then later in the unit, we do a little lab, which I'm sure a lot of you guys already do, called Avogadro and the mole unit. I really like this lab because it does a couple of things. It helps students see like the actual substances that we're working with, like this is what copper sulfate looks like, this is what calcium looks like. It helps them review some of their nomenclature that we did earlier. And then of course, the whole point of this lab for me is for them to get some more practice in that's not necessarily a worksheet. So I'll have students calculate the moles to grams, and so on. And so between that opening activity and this Avogadro and the mole lab, I'm stressing that this mole is a tool that helps us connect what like the microscopic world to like our real life world and how we can count those numbers of atoms by measuring the mass. After students have practiced, done their mastery check, done their labs, we of course need an assessment. I always say my assessments aren't that flashy. It's really just a mix of multiple choice and free response. In this unit, I do tend to put more of an effort or an emphasis on the free response questions. They're like math problems, these mole conversion problems, because that's really what's important in doing this unit. One thing I just want to stress or kind of give a little teacher tip for is over the years, I've come up with a consistent way that I grade their math problems or their mole conversion problems. And then this carries on into the stoichiometry unit. Usually the problem is going to be worth 3 points. And I'll give them a point for showing their work, a point for getting the answer in what I call the ballpark. If my answer key said like 23.58 and they just wrote 23, I'm going to give them that point. And then that third point, a half of it comes from writing the units, because as a chemistry teacher, I always joke, chemistry teachers are crazy for their units. And then I give them a half a point for writing it in the correct number of sig figs. And I use that rubric, if you want to call it, from the beginning of the unit all the way to the end, so the students know that even if maybe they don't know how to solve the problem, that the work is going to be counted and they can at least get partial credit for that. Now, if I have a double conversion problem, or later when we get into stoichiometry, I'll probably make those problems worth 4 points, an additional point for doing that extra conversion in there. Then after we take our assessment, I always like to ask the kids, do you feel like you have seen everything on this test before? And usually the answer is almost always yes. And that's because we've had the mastery checks, we've had the practice tests, so they feel like they've always seen it. I always like to make a point about how much they've learned throughout this unit. At first they were, oh, I don't know how to do this math. And then at the end, they have like ingrained this sequence of steps in order to solve these problems. And then I also try to tell them when they get the test back, we try to look it over, and I'll ask them, if you're going to take a retake, what skill do you think you need to learn before you take the retake? I also want to mention that I sometimes will include some fun extension activities. I like to do the activity where the students sew the mole, and there's a template that you can find online for this. The kids will use the paper template. They'll cut out some fabric. Sometimes kids have used like socks before, or kitchen towels. They'll sew their mole. I really encourage them to try to make a theme or a name with their mole, and then we'll vote on which mole is kind of like the best mole, or like the funniest mole at the end, or like most creative. And I know it's not really chemistry related, but it does give students a mental anchor that's playful and that they'll remember when they leave chemistry. Another thing that I'll sometimes do is I'll have a mole Olympics. And so this just involves the students doing some problems, measuring out a mole of some different substances, just some fun competitions between different groups. And why these activities don't replace direct instruction or practice, they just enhance the experience of the unit. Doing this math can be frustrating for students, so I like to just incorporate this fun. And then I personally, as a teacher, I have fun with it. I think it makes my class a little bit more special, a little bit more memorable. And finally, just to close out, if I was just to give you one piece of information or one tip, it would be that students really need to show their work. I remind them that we are behaving like scientists, and when scientists are doing their lab notebooks, you need to be able to follow their reasoning throughout, and so they need to show their thinking or make their thinking visible, and so that's what we're doing when we're showing our work in class. Another reason I tell students is that they can use the units in their calculations to help ensure that they've set the problem up. If all their units are canceling out correctly, then they know that they set their problem up correctly and that they'll most likely get the correct answer. Showing the work helps me better understand what they were thinking. So if they needed help to solve a problem, I can look back at their work and see where they started and where they're going. If it's just a bunch of numbers, I'm not really sure what they were talking about. So using the units is not only the correct thing to do, but it's also going to support them and me in helping them learn more. So I hope you enjoyed this new format. I'm looking at the time and it's definitely more lengthy than some of my other podcasts. If you like this format, let me know. If you're like, yo, lady, go back to the shorter podcasts, I definitely could do that. But overall, for this mole unit, I just want to let you guys know that really my idea is that when students leave this unit, I don't want them to think of just passing the test. I want them to know that they can do hard skill-based chemistry, and then this supports their belief that they can do this chemistry, especially as we move on to a more complicated math in a couple of weeks of stoichiometry. As always, thank you for listening to today's podcast. I know teaching chemistry can often feel overwhelming. My hope is that this episode gave you one idea, one strategy, or one small shift that you can take back to your classroom. If you found this episode helpful, please share it with another teacher who might need a little assistance or just wants to feel like they're not alone in the classroom. And until next time, keep inspiring, keep experimenting, and keep being awesome in your chemistry classroom. Happy teaching.